Okay, what we're going to do is the practice problems that are assigned for tonight or for the weekend. And this is number 1 on page 565. So, your job in doing this is one time for number 1, you would write equilibrium constant. Okay, that's the directions, right? They apply to all 3, so just write it one time. Right? So, in letter A, we have N2O4. And that dude is the gas. So we know, will that be included in the equilibrium constant? Yeah, absolutely. Okay, we get the back and forth arrows because it's an equilibrium reaction. And we got 2 NO2 that are also gases. Now, we're also supposed to write the equilibrium constant, but what I've just written here by letter A is the question, right? The question is, with this formula, what are we going to have for an equilibrium constant? So, K sub EQ. Who knows what's on top? Products or reactants? Product. But there's only one product.
And squared. Do square.
Squared because the coefficient. Very good, Kelvis. Okay. What's on the bottom? Reactant in this case, which is N2O4. And it would be a good idea to write the little deals in here, the phases. This is a gas. And we're done. That's it. This homework is going to go really fast. Okay? Okay, let's go to the other page. What page is it?
Page 568.
Okay, page 567, I think.
No, 8.
I don't think so. Not in my textbook. And you go. There. So, we're going to write the directions. Right? Equilibrium. Constants are expressions. This is expressions, not constants. The constants coming later. Expressions or heterogeneous. For heterogeneous reactions. What are heterogeneous? Solids and liquids. They have solids or liquids, or both. So we're going to have to distinguish those. Let's put our little A down. This is question number 2, and that's the directions. Letter A. I don't have to write the directions for B, C, D, and E. Okay, I just have to write them one time. So I've got C10H8. And what kind of stuff is it? Oh, it's a solid. It is in equilibrium with C10H8 gas. Oh, that's weird. C10H8, and this guy's gas. So, here's what I recommend you do for these guys. Write the equilibrium expression as if you had a homogeneous reaction, which is like this. C10H8 the solid, whoops, guess what? Is he going to be on top or bottom?
Is he gonna be on the bottom?
He's going to be on the bottom. You bet. Okay. Okay, and on the top, we have C10, H8, the gas. And brackets. Now, why do you want to do this? Because you cannot ignore this so far as making the equilibrium expression. This is KEQ. So what am I going to do? I'm going to cross that guy out. Excuse me. If I leave this as the only thing, it will be wrong. And what I'm pointing to right now, so if this guy gets crossed out, when he gets crossed out, we have to put a 1 there. Because this guy is on the bottom of a fraction. You can't just throw away the fraction. Okay? So, what we wind up with is 1 over C10 H8 as the solid in brackets. That's it, folks. Pretty easy, huh? Okay. Thank you for watching. Or delete. After class, I decided to continue the video for a couple of reasons, one of which I didn't realize, and that is that I had crossed out this guy. And this guy is the gas. He does not get crossed out. We cross out solids and liquids, pure liquids. So this is the guy that gets crossed out. And so when this goes away, it becomes a 1. And then this guy becomes our dude on top. And the final answer then becomes this guy down here. Okay, so that's what happens in heterogeneous equilibria. But I wanted to show you this one because with this reaction, we're going to have something else happen that did not happen up here. So let's go forward with that right now. So the case of equilibrium for this guy, of course we want to go to this side to get our top of our fraction, because products are always on the top. So we look at that and you see that we have the CO2 and the iron. There's no exponents because there's no coefficients in the balanced equation. And we have the solid and the gas, and of course we're going to have to get rid of this, but we want to see where this guy is in the whole grand scheme of things. And so we go down here and we see that we have another solid, okay, from here. So this solid is going to have to go away as well. And the carbon monoxide from here shows up like this. So now we see this guy has to be crossed out, and that becomes a 1 in my next fraction, right there, and the carbon monoxide stays because that is a gas. Well, this guy up here is going to have to go too because he's a solid, and so we're going to cross him out, and of course the CO2 will stay, and what we have in the end is just CO2 on the top and carbon monoxide on the bottom. And so whenever we cross anybody out, we have to put a 1 there, but of course that can go away, and it serves as a placeholder so we know where these guys belong in the entire fraction in the final writing of it. And that's it for now. I hope this has helped you a lot. Good luck with your homework on the weekend with the rest of these. Sorry to keep adding things on, but I wanted this one to be here as well, because here's where we see that what is out, as we just saw, solids, but liquids are also out. Pure liquids cannot be in the K equilibrium. What is in is the aqueous and the gas. And that wraps it up. I'm done this time. Have a nice weekend, and thank you for watching.